Hi everyone, I'm Ramesh Chandra. I'm a software engineer at Databricks, and I'm going to talk about Unity Catalog, catalog for data and AI. Okay, so here is a quick overview. I'm going to motivate the need for Unity, how Unity Catalog solves the problem, and then maybe, depending on time, go over like current features and what's coming in the future. Okay, so let's start with the basic question. What's a catalog and why are catalogs important? Right? Catalogs are the source of truth for your critical properties about your assets. So what does this mean? Let's take an example. Today we have a very popular catalog is Hive Metastore. And Hive Metastore stores the metadata for all your tables. This includes table name, schema, like your column information, storage locations for where your data is stored on cloud storage, the format of the data, and its created, type, etc. Right? So this is traditionally how catalogs were thought of as a way to store all your tabular data information. And this has been since more than a decade ago. But what we have seen recently is catalogs have started to expand their role and take on a lot more responsibilities. So we've seen catalogs take on governance and access control functionality. This includes roles, permissions, policies like masking policies, access audit logs, and so on. And in addition to table types, we also seen catalogs are expanding into unstructured data like files, images, and also supporting all the various AI and ML assets out there, like models, GenAI tools, and so on. And moreover, catalogs are also becoming a critical piece for complex data warehousing functionality, database functionality like transaction management. For example, multi-statement transactions, multi-table transactions, and so on. So yeah, so this is what we've seen over the last couple of years in Databricks as well. So 3 years ago, we started the journey on Unity Catalog as a next generation version of Hive. And today we have a large number of our customers, more than 10,000 are using Unity Catalog. And earlier this year, we saw that the overall ecosystem, the open source ecosystem doesn't have this next generation catalog. So we worked on open sourcing the most widely used functionality in Unity. And that on that journey, we are like going to get more and more functionality into the open source version of it. Okay, so next on to the next important question. Catalogs are the source of truth for your metadata and governance, but how do I get all my engines, my tools, my platforms, all of them to integrate with my catalog? And this is very challenging today because most data platforms out there lack open access. And we have data assets and the AI assets are separated from each other, siloed, which makes governance across all of these assets inconsistent. It's very hard to do that. And if you talk to any enterprises out there, all enterprises care about governance. They want to make sure that the data is governed, the life cycle is very well managed. So it's super hard to do this today. And let's look at some examples to kind of drive home the point. So take a simple example. We have all of our tables stored in the data lake on cloud storage. And let's say we have a catalog like Hive managing this data and engines like Spark or Flow accessing this data. This is a pretty straightforward example. This is very easy to set up. Many enterprises today set up data platforms this way. But the newer use cases requires different tools. So you might have a user using DuckDB to do analytics, or they might be using, finance team might be using Snowflake, Tableau to do reporting. And once you do that, now integrating this becomes hard because some of these platforms are not open, and they might be storing their data in a proprietary catalog which doesn't have open access. So what this means now, you might have to mirror the metadata between these catalogs, or sometimes you might even have to create copies of the data so that just to give access to other tools. Right, and so if you extend this and go to the newer types of data, like image training data or file data, then many of the legacy catalogs don't have supports for these types of data, right? Hive doesn't support files. So that would mean that you need to introduce another catalog. And now you see how the architecture will start becoming complex. You need to have like all these catalogs synced and kept in sync with each other, and it starts creating metadata silos. So you have a lot of work to keep this data in sync. There's got duplicate copies of the data out there. That's additional cost. And if there is a mistake, or if your sync is stops for any reason, then you're working on stale data, right? So that's the problem. Just to summarize, because of all the fragmentation that is there out there, we have these metadata silos that are created, which leads to a lack of a unified view across all of your data and AI assets, and this requires all your administrators and users to stitch together all this data, both for governance, for figuring out lineage, for auditing, and so on. So what's the solution? We call this an open lakehouse, and when we talk to customers over and over again, we hear that what they are looking for is a central catalog that manages all their assets, their data assets, their AI assets, their files, their images, everything together, and provides unified governance across all of them, so that they can define policies in one place, and the policies apply whether you're accessing the data as a file, or whether you're accessing it as a table, or whether you're accessing it as part of like a training data set. And they would also want it to be open without lock-in, making sure that every engine out there can access and read and write from it. Right. So that's that's what customers are looking for. And so that's overall, like the Unity catalog was intended to solve that problem, with being multi-format, supporting all the different types of table formats out there: Delta, Iceberg, Parquet. Multimodal, supporting beyond tables, supporting files and AI assets, and with unified governance. Okay, so if you don't take anything else from the talk, this is the kind of the key thing I would like you to take away. We want to make the open lakehouse a reality, and the way Unity Catalog enables that is by providing this multi-format support, and by supporting tables, different table formats, different AI ML assets, and exposing that through Unity REST API, which natively supports all these formats, but also through other standard formats like Iceberg REST Catalog interface, which is used for tabular assets, and Delta sharing for sharing. And we are working with a variety of partners to support a broad ecosystem. So we're working with the cloud platforms, we're working with Daft, Lance, and all the AI innovators out there. We're also working with the traditional compute engines like Trino and DuckDB to support this overall ecosystem and have this central catalog. Yep. So that's the overall vision. And as I said, you see, Unity is open source, and we have. I'll quickly go over a few features that we have supported today, and something that's coming up in the future. So all the assets, all the resource types that I mentioned are organized into this 3-level namespace. And the 3-level namespace is pretty standard in data warehouses, and that's the reason why we picked this for interoperability. And currently we support catalog, schema, and the standard tabular and some AI asset types. And in the future, we'll have views, locations, credentials, and so on. So one of the core functional building blocks we have for governance is credential vending. And the credential vending is the ability for a catalog to vend credentials to cloud storage. So basically give access to an engine to cloud storage, so that you don't need to give ambient access to the engine. So what this is it's a time-limited scope-down credential that gives access to one object in your catalog. So that object could be a table, it could be a model, it could be a set of files, and by doing this, then this becomes a building block on top of which you can build other governance, other higher-level access policies. So this leverages the existing downscoping mechanisms that cloud storage providers have. So the way this works is the user sets up Unity with access to all of the storage and defines policies in Unity. For example, it could be SQL grants. It could be later on, it could be more advanced policies like ABAC. When the engine comes in and asks for access to a particular table, Unity will vend a temporary credential just for that table and give it to the engine so that it gets access. And this allows the administrator to be able to control all of their governance in one central place, with the engines being able to get access as needed. So this was lacking in all existing catalogs. This is a core building block that was needed for us to support broad governance. So Unity also supports ML models. This uses the ML flow standard format for packaging all the model artifacts, and the interface it provides is a model registry interface. Right? So the abstractions are like register model and model version abstractions, and we have support for ML flow integration. The client here it connects to both the ML flow service as well as Unity. And when it needs to register a model, it uses the model, Unity's model registry interface. And these models, as I said, are also governed. So if you any other tool can get access to the model using the permissions on defined in Unity. So on the topic of permissions, we have identity and authentication. You can use integrations with an external IDP like Google and support SCIM for user management, JWT tokens for authentication, and for authorization we have object level grants, which is very similar to SQL grants, but they're extended to all the other resource types, whether it's volumes, whether it's models, and any additional resource types we have in the future. So Daft integration, there are a few. We are, as I said, we're working with many partners to do integrate with various engines out there, and so I'll give a couple of examples here: Daft and Spark. Daft integration is pretty straightforward. You install the Daft Unity connector, and then point your Daft to the Unity catalog server. This is the basically, you need to give the endpoint, which is a catalog server, and you need to give the token. This token is the identity token for Unity. Right? Once you've done that, you can start working with your data. And behind the scenes, what happens here is Daft goes and uses this token to talk to Unity, and that gives it access to the tables that the user has access to. And when they list out, they only get listed out. Only the tables that the user has access to will be listed, right? And when they're accessing the data, they can only access the data that the user is allowed access to. And a similar integration with Spark. Again, you set up Spark with pointing to the Unity catalog and the token that the user, same token that Daft uses. So in the future, there is a lot more other things coming in. We'll have transactions support with Delta coordinated commits. We have full Iceberg REST catalog support. Tool support for GenAI tool support, because we already have function support in there. Spark integrations for all the non-tabular data sets, volumes, functions, and grants, and Delta sharing interfaces and so on. So yeah, so here, if you want to try it out, unitycatalog.io, and this is the GitHub link, and happy to take questions.